Welcome to the deep dive. Today, we're going to be looking at this really interesting research paper from MIT.
Okay.
It's about pushing the boundaries of what language models can do,
Right.
specifically in the realm of abstract reasoning.
Yeah, abstract reasoning with language models.
So we're talking about like visual puzzles
Right.
with shapes and patterns
Yeah.
that kind of make you feel like you need
Uh,
a secret decoder ring.
it's really intriguing,
Yeah.
this area of AI research, because abstract reasoning has always been seen as this uniquely human capability.
Yeah.
And this paper focuses on the abstraction reasoning corpus, or ARC as it's called.
Okay.
It's a benchmark data set of visual reasoning problems that have proven to be very
Right.
challenging for AI systems to solve.
So ARC is like known for being a really tough one to crack.
Yeah, definitely.
What makes it so difficult for AI?
Well, for traditional AI approaches, I guess.
Yeah.
ARC puzzles are tough because they require a level of generalization and flexible thinking that goes beyond simple pattern recognition.
Gotcha.
The tasks are novel, the format's unique, and the solutions often invite understanding underlying rules and relationships that aren't explicitly stated.
Interesting.
So traditional language models, which are great at, predicting the next word in a sentence,
Yeah.
they kind of struggle with these problems.
Makes sense.
Yeah.
So how did the MIT researchers approach this challenge?
So they use a technique called test time training, or TTT,
Okay.
which essentially allows the language model to learn and adapt while it's trying to solve the problem.
So that's pretty different
It is.
from the usual training methods.
Yeah, it's a pretty radical departure from
Yeah.
the usual training methods for language models.
Could you maybe break down how TTT actually works?
Sure. So imagine you're trying to learn a new board game.
Okay.
Instead of just reading the rule book and then playing.
Yeah.
Imagine if you could get hints and feedback from an expert as you play, allowing you to kind of learn and adjust your strategy in real time.
Yeah.
That's kind of what TTT does for language models.
Gosh.
It allows them to update their parameters,
Okay.
improve their understanding of the task while they're actively trying to solve it,
Wow.
using a loss derived from the input data itself.
So instead of being static,
Right.
the model is actually like evolving as it's working on the problem.
Exactly. It's dynamic.
Wow.
And the researchers found that this dynamic learning process,
Okay.
when combined with a few other clever techniques,
Right.
leads to some pretty impressive results.
I want to get into those techniques.
Sure.
What were the key ingredients
Yeah.
that made TTT so successful on ARC?
So the first key ingredient was fine-tuning.
Okay.
Before tackling the ARC puzzles, they gave the language model some practice on similar tasks.
So kind of like warming up?
Yeah, exactly, like warming up before a big game.
Gotcha.
Interestingly, they found that fine-tuning on tasks created by another large language model didn't work quite as well as they expected.
Interesting.
It seems that human-generated challenges are still superior
Wow.
in terms of preparing a model for the complexities of ARC.
So even in the age of advanced AI,
Yeah,
there's still something unique about the human
there is.
design challenges.
It seems so.
What was the second ingredient?
So the second ingredient was what they called augmented task generation.
Okay.
This involved presenting the language model with variations of the same puzzle during TTT.
So different ways of looking at it?
Yeah, think of it like showing the puzzle from different angles
Uh-huh.
or with slight variations
Gotcha.
to force the model to learn more robust and generalized representations of the underlying concepts.
So making it work harder?
Yeah, they're essentially making the language model work harder during training
Right.
by introducing more diversity and complexity.
No pain, no gain.
Exactly, no pain, no gain.
So what was the final ingredient in this recipe
Yeah.
for reasoning success?
The third key ingredient was individualized learning. Okay.
They trained a separate adapter for each puzzle instance,
Okay.
allowing for specialized expertise on specific problem types.
So it's like having a team of specialists,
That's a great way to put it.
like
Yeah.
each one
Yeah.
trained to tackle a particular...
Exactly. And by combining these three elements, fine-tuning augmented task generation and individualized learning,
Right.
they were able to unlock a surprising degree of reasoning ability
Wow.
in their language model.
Okay, so they've got this powerful combination of techniques
Right.
working during the training phase,
Yeah.
but they didn't stop there, right?
They didn't stop there.
You also had this clever strategy
They did.
during the problem-solving stage.
Yeah, during the problem-solving stage itself.
Can you tell us about that?
You're referring to augmented inference, right?
Yeah.
Yeah, essentially they used geometric transformations like rotating and flipping the puzzle
Okay,
to create multiple versions of the same problem.
gotcha.
They let the model try to solve each version.
Right. And then combine the results using a voting system.
Okay.
This helps overcome biases and increase the model's confidence in its predictions.
So it's like getting a second opinion
Exactly.
or multiple second opinions
Yeah, multiple second opinions.
from the AI
Right.
to make sure it's on the right track.
Uh-huh.
But let's get to the part that I think everyone's waiting for.
Sure.
The results.
Yeah.
How well did this combination of TTT and augmented inference actually perform?
Well, the results are pretty impressive.
Okay.
The best performing language model achieved 53% accuracy on the ARC public validation set.
53%.
53%.
Might not sound like a lot,
Right.
but I imagine considering
Yeah.
how much traditional language models have struggled.
Oh, yeah.
This is a big jump.
This is a significant leap forward.
Yeah.
It really highlights the potential of these new techniques for improving AI's abstract reasoning capabilities.
That's fascinating.
Yeah, it is.
We've covered a lot of ground already.
Yeah, we have.
I'm really curious to hear more about the implications of these findings.
Yeah.
We'll dive deeper into that
Oh,
just
wait.
a bit.
Sounds good. So this 53% accuracy,
Okay.
it represents a significant jump over previous neural network approaches
What?
to ARC.
Yeah.
It suggests that we don't necessarily need to fundamentally change the way language models work to achieve better reasoning abilities.
So it's more about finding the right ways to train and use them.
Exactly.
That we already have.
It's like finding the hidden potential within these systems.
Cool.
The researchers also found that when they combined their method with another system called BRC, which uses program synthesis, they actually achieved an even higher accuracy of 61.9%.
61.9.
Yeah.
That's getting close to human performance.
It is. That's getting close to average human performance on ARC.
Wow.
This finding further supports the idea that combining different approaches, each with its own strengths and weaknesses, can lead to even more powerful and robust AI systems.
So it's not just about improving a single model.
Right.
It's about thinking more broadly.
Exactly.
About how to integrate different AI tools and techniques.
It's about leveraging the strength of different approaches and finding ways to make them work together.
Really interesting.
Yeah.
But before we get too carried away,
sure.
What are some of the limitations or challenges
what are some of the downsides
associated with this research?
Well, one limitation is the computational cost.
Okay.
Running these experiments, especially at scale, requires significant computing power, which may not be readily available to all researchers or developers.
Of course.
This raises questions about accessibility and the potential for these techniques to be widely adopted.
Yeah, that's a common challenge, I think, in AI research.
It is.
Pushing the boundaries often means pushing the limits of our hardware.
Exactly.
Are there any other limitations?
Another concern, although not directly addressed in this paper, is the potential for data leakage.
Okay.
The ARC dataset is publicly available, meaning there's a possibility that some of the language models used in the study might have been exposed to some of the puzzles during their pre-training phase.
So they might have seen some of these before.
Yeah, there's a chance that the models might have seen some of these puzzles before, which could inflate their apparent reasoning abilities.
Yeah, that makes sense.
It's a valid concern.
Yeah.
Ensuring that AI systems are truly learning and reasoning and not simply memorizing patterns they've encountered before is crucial for evaluating their true capability.
It's important to be rigorous
It is.
in our evaluation methods.
Yeah.
But despite these limitations,
Yeah.
it sounds like this research is a significant step forward
It is.
in our understanding of how to improve AI's reasoning abilities.
Definitely.
It opens up some exciting possibilities
It does.
for the future.
Absolutely. It's still early days.
Yeah.
But research like this offers a glimpse of what might be possible.
It's really incredible to think about the potential applications of this technology.
Yeah.
Imagine language models that can reason about complex problems in fields like medicine, engineering, or even art.
The possibilities are vast.
Yeah.
If we can teach AI to think more logically and abstractly, the potential applications are almost limitless.
It's a really exciting time
It is.
to be working in this field.
Definitely.
But for our listeners who might be feeling a little lost in the technical details, can you summarize what this all means in a more practical sense?
So the core message is that we're making significant strides in improving AI's ability to reason and think more like humans.
Yeah.
We don't need to completely reinvent the wheel
Gotcha.
to achieve this
Okay.
by finding innovative ways to train and use existing language models.
Right.
We're unlocking hidden potential.
Within these systems.
It's like we're giving these AI systems the tools and techniques
Exactly.
to learn and adapt on the fly,
That's a great way to put it.
just like we do as humans.
Techniques like TTT augmented inference and the use of specialized adapters are revealing
Right.
a surprising capacity for complex reasoning in AI systems.
Wow.
A capacity we're only just beginning to understand.
So as we wrap up this discussion,
Sure.
what's the one big question you want our listeners to ponder?
Okay.
What's the thought-provoking idea
Yeah.
that will keep them engaged and excited about the future of AI reasoning?
So this research has shown that AI can achieve near human performance
Okay.
on specific reasoning tasks.
Right.
But the next big hurdle is to create AI that can generalize that reasoning ability
Okay.
across different domains and problem types.
Interesting.
How do we move from specialized reasoning to more general intelligence?
Right.
That's the real challenge.
Yeah.
And it will require continued innovation and collaboration, of course.
In the years to come.
That's a fantastic question to leave our audience with.
It's a challenge worthy of its own deep dive.
It is.
Yeah.
Yeah, it really makes you wonder what the next breakthrough will be.
It does.
Where do we go from here?
Right.
What are the most promising avenues for future research?
Well, one exciting direction is to explore how to make test time training more efficient and accessible.
Right.
As we discussed earlier, the computational demands of TTT can be a barrier for wider adoption. If we can find ways to reduce those demands, it will open up these powerful techniques to a much broader range of researchers and developers, which would accelerate progress in the field.
So democratizing access to these tools could foster more innovation.
Absolutely.
What about other avenues?
Another exciting avenue is to investigate how these techniques can be applied to other types of reasoning tasks beyond visual puzzles.
So beyond these puzzles...
Yeah, imagine applying TTT and augmented inference to challenges in natural language understanding, problem solving in real-world scenarios, or even creative tasks.
Wow.
Like generating art or music.
So instead of just teaching AI to solve abstract puzzles, we could be teaching it to think critically and creatively.
Exactly.
In ways that are much closer to human intelligence.
That's the ultimate goal.
Yeah.
And this research suggests we're moving in the right direction.
It's really mind-boggling.
It is.
To think about the possibilities.
Yeah.
If AI can start to reason and think more like we do, what kind of impact could that have?
The potential impact is enormous.
Yeah.
Imagine AI systems that can help us solve complex scientific problems. Design more efficient and sustainable cities. Personalize education and healthcare, or even create new forms of art and entertainment.
It sounds both exciting
It does.
and a little daunting.
It is.
At the same time,
Yeah.
as we've discussed, there are still many challenges to overcome
Lots of challenges.
before we reach that level of AI sophistication.
But the progress being made in AI reasoning is undeniable.
Right.
This MIT research is just one example of the incredible advances happening in this field.
For sure.
It's an exciting time to be involved in AI research.
Yeah.
I'm really eager to see what the future holds.
Me too. Well, thanks for sharing your insights with us today.
It's been my pleasure.
It's been a fascinating deep dive.
Yeah, it has.
Into the world of AI reasoning.
Absolutely.
And to our listeners, we hope you enjoyed this exploration
Yes.
of cutting-edge AI research. Until next time, stay curious